Hey guys, welcome back to another episode of Simulators. Today we're continuing what we did yesterday, which is working on the Monte Carlo stuff. Now I know some of you guys were pretty excited to continue working on the Huffman stuff. We are kind of hopping around right now. I think, see, the problem is this, I need to make a YouTube video this upcoming week. I got all the audio done as of this past weekend. Well, most of the audio done. How about this? I've gotten about half of the video and a quarter of the audio done, but the video was the kind of, I guess, easy stuff to do. Now I've got the hard video to do and the easy audio. So it's kind of like probably 50% done right now. Then I got to do editing, which will probably take like 6 hours or something like that, just like normal. So what I need to do is I need to get done with all of the extra visual simulations and stuff like that as soon as possible, and then do the editing as soon as possible, so I'm done by Saturday. The stream usually picks up once it gets going. It's a shame it's hidden in the creative section. I miss the programming section. Yeah, Utama, I totally agree. The creative section is a very weird place for a channel like this one. But that's how it is, I guess. So that's another reason why I kind of switched the idea of this channel around. So it used to be that this channel was focused exclusively on computational physics programming. Now it's basically about creating simulations for my YouTube channel. In the end, the content hasn't changed, but the idea behind the channel has. And I tried to stress this when I came back from the US. It's not really that you guys are going to be seeing anything different. It's just that now the way I choose content is a little bit different. And it's just because Twitch clearly doesn't care about its programmers. So it's a situation where, you know, I had a choice to make, and I figured, look, it's good to continue doing live streaming. I like it. I presume you guys like it, but at the same time, Twitch apparently doesn't. So it was a weird situation there. Anyway, we're going to continue working on the Monte Carlo stuff. Let's go ahead and pull up what we got done by the end of yesterday, which I did work on the side a little bit. So let's do Mirage. Then what do we want? We want frames, animation, dot graphics interchange format. Okay. So this is where we're at right now. Okay, we can officially generate everything we need to generate, and it's all good, right? So we have our little box being created. We have red dots in the middle, or sorry, red dots on the outside, green dots in the middle, and then we stop when we get under some sort of threshold. That's exactly what you might expect Monte Carlo to work like. However, there is a subtle thing that is wrong about this simulation, and I could say, hey guys, do you know what it is? And you guys would be like, oh, of course I know what it is, if you know Monte Carlo. Here's the problem. So let's go ahead and do this. Open up Zernal and get started. So, Monte Carlo. How does this work? Well, let's take a second and talk about it. So, Monte Carlo works with random numbers. Okay, so oops, I don't know why I put a question mark there. So this means if we've got our little circle, let's draw a circle. And if we got our square, pretend I can draw a square. Ah, that one worked out pretty well. Okay, if we got a circle, we got a square, and we're choosing random points on the circle and square. Let's say, you know, whatever. Just picking points at random. Okay. Now, this means that if we're picking points at random on the square and we're putting them inside the circle and such like that, more than likely, we will not find the area immediately. So there is a probability. Oh, one second. Ability of finding, let's see, the area quickly. And that's great. However, more than likely this won't happen. So the Monte Carlo algorithm works. I'm just going to say MC works with many iterations. Now, there's a couple of different ways to do this. The first way is we just stop at the threshold that we're stopping at, right? And whenever people see it on video, I tell them, hey, look, an actual Monte Carlo algorithm would have hundreds of thousands, sorry about that, of more iterations. Or we can do it another way. And this is what, man, I'm sorry about the yawn, guys. And this is what I want to do. I want to start by visualizing a single dot. The next iteration I want to visualize 2 dots. And the one after that, I want to visualize 4. Then 16. Then 32. Then 64. So on and so forth. Until we get to 1024. And that'll be the maximum size of our array. Okay? And we visualize 1024 every single time step. That way we can get done with 100,000 iterations and show that our Monte Carlo algorithm does indeed give us the area after so many iterations. Right now we're doing like 20 and we're getting a good result. So we're going to see how long it takes to get the result that we need. But I think if we do it this way, it'll work out pretty well. So we'll see how far we get. Okay, so that's kind of the idea for today. We are going to redo the way that we are putting in dots. Hopefully it'll look good. I don't know. We'll see how far we get. Let's see, what else is there to do? Outside of that, if we finish early, which we might, because I don't know how long this is going to take, but if we finish early, we're going to get started integrating another function, which I think is super cool and interesting, which I guess I'll introduce now. So one of the advantages to the Monte Carlo algorithm is that we can integrate arbitrary I'm going to put down misbehaved functions. Okay, so what does this mean? Well, it means that we can integrate almost anything. If we've got a square, right, and we have some sort of weird blob inside the square, so long as we can tell what's on this side and what's on this side and what's in the center and what's on this side and this side, or what's on this side in the center and this side, as long as we can tell what's in the middle, we can integrate it. And that is kind of the beauty of Monte Carlo. So what I wanted to try was integrating a very particular symbol, which looks something, forgive me, I'm very bad at drawing, like, pretend I can draw the bat symbol. I can't draw it, so let me just show it to you guys. I wanted to integrate, one second, this guy right here. We have equations on how to plot it. So in practice, or in theory, we should be able to go through and basically figure out whether a point that we have generated is within the bat symbol or not within the bat symbol. And then I want to do a Monte Carlo integration of it. I think this is going to turn into a super cool animation that we can show for the video. And I think it'll get people really interested in Monte Carlo simulations and stuff like that. I think. We'll see how it goes. The nice thing about this is that the area is analytically determinable, and it's like 194 over like 70 or something like that. So they know the area, and it's just a matter of going from that and finding our percent error, seeing how far off we are. So that's pretty cool. Pretend I didn't draw that, because that was pretty bad. Did not draw anything. Anyway, guys, I think at this point, because there isn't really very much to introduce, we can go ahead and get started. Hey, Ike here. So I'm going to go ahead and get a quick sip of water, and then we will get started soon after. Again, guys, sorry for the shorter introductions. It's just at this particular point, there isn't so much to introduce. So I figure it's probably okay to do the shorter introductions. Alright, good to go. So let's pop this over to this desktop, that to that desktop. I'm going to keep the GIF up over here on the side as we go ahead and continue further into the Monte Carlo layer of, I don't know. Okay, so we're going to CD back into the appropriate directory, which will be, I think, Simuleos, Visualization, and Monte Carlo. Okay, so we have Monte Carlo Viz, the executable. Then we have Monte Carlo Viz.cpp. So let's go into vi Monte Carlo viz.cpp. Okay, so we've got everything we need right here. Let's scroll down to the Monte Carlo algorithm, but first, let's go ahead and get this guy back to normal. Again, like I said, we need to draw the Batman function for later, So I have that written down for later. But for now, we don't have it. So I'm also going to go up here and change the number of frames from 1 to maybe, I'm going to say 300 should be enough. It's almost enough, but I think it should be enough. Okay, so this, for example, is 310 frames. So I think it's okay. Okay, so now let's go down to the Monte Carlo algorithm. Okay, so the first thing we need to do is every time we have a vector, we need to go ahead and define it as a particular size. Then we have to figure out how to draw the points appropriately. So really quickly, I'm going to get another sip of water and then we can get started. Sorry, I'm just super thirsty today. Okay, so you'll note here that the very last simulation I did had a count of 100,000, which I think was fair enough. So what I want to do is a very similar system. So 100,000 I think gave me good results that I could use for this particular, for this upcoming video. So let's change all of these guys so that they have a set size of 1024. 1024, 1024, and 1024. Okay, so now the next question, where are the next vectors? These vectors are also going to have 1024. Let's go ahead and put a period. Period. Okay, any other vectors I missed? I think that's all of them, but just to be sure, let's do a quick search. Vector. There. There. And that's it. So let's go up here. See print. Yeah, that should be fine. Okay, so last time, because the way I was doing it was a little bit differently. What I was doing was I was basically creating a giant, I suppose you could say, matrix, a giant array or vector of all these points. But if it's 100,000 size, it takes a very long time to go through. So we want to do it more dynamically. 1,000 in size isn't so bad. So what are we going to do? First of all, let's go over to the top because there was a bug yesterday at the end of stream, which I want to reactivate actually. And I'm going to explain why in just a second. So the bug, hey OC Master, how are you? So the bug that you guys might have remembered was that the area was overwriting itself, right? And so we kept having these situations where the area kept like writing right over itself, and that's because I didn't have this fill rectangle thing in. So in other words, the background was clear, which made it so that as we were converting it to a graphics interchange format, it continually just put it on the previous one. So we were writing not only the frame itself, but also all of the previous frames to every frame in the GIF, if that makes sense. So what we need to do now is change this so we don't have the rectangle anymore, but I want to put a black box behind the area and the percent error, and then we'll see how far we get. So this means when we do the print area function, and also, hey Summer Gamer, and also the next area, the print area and percent error, the print area and print percent error functions should now also draw a black box underneath it so that we get basically the same thing in the end. So encircle print area. Okay, so what are we going to do here? Well, we have Cairo set source RGB. That's fine. Color red, color green, color blue. That is also fine. But here's what I want to do first. Before doing any of this stuff, let me go here and let's draw a black box under the top. So the size of the text, I believe, is 20. Oh, we can figure this out quite easily. Okay, here's what I'm going to do. I'm going to say drawing black box underneath 1 second area. Okay, now we're going to say let me see, so we move it to 2020, and I think if we put the black box from 2020 we'll be fine. So let's do Cairo set what do we want? Set source RGB, and we want to set it at the current frame context. So this guy right here. And then we want to say, we want to give it a particular color, which is black. And I believe that's 0, 0, 0. Let me see. I think so. Let's go to the top. Let me go down to the init function. That's fine. Here it is. Nope, here it is. And it is a Cairo rectangle, that source RGB, double RGB. It is indeed black. Okay, so let's go down to the bottom. And let's see what we got. Animate Batman, that's not what we need. Print P. Okay, so 0, 0, 0 is now black. Let's add in a semicolon because otherwise it will not compile. And see what we got. So, string, area text, number. Okay, so now we need to create the rectangle. So it's going to be Cairo rectangle. Is it set rectangle, draw rectangle? I think it's just Cairo rectangle. We give it the context we're going to draw on, which is this one right here. And then we say where it's drawing to and from. So 0, 0 is where it's going to start. And then we want it to be the size of whatever in Y. So we're just going to create a giant line across here and 20. So in X, it's going to be anim.resolution X. And the other guy is going to be 20 in Y. Okay, sounds good to me. And we're going to do the same thing for, one second, the next simulation, which is going to be down here. So let me see, where are we? We need to do the same thing for this guy, %error. And let me also just copy this because it's going to be the same thing, except for %error. 2% error. Okay, good. So where is it going to be put? Well, it looks like it's going to be put, let me see, move to anim frame context. So I guess it's going to be anim resolution Y, and then 20. So where are we? X, Y. So this is going to be anim, well, if I can do it correctly, anim.resolution Y minus 20. Now it popped over to the next line, so I'm going to pop these guys over to the next line right here. Okay, so now we should be able to run the same simulation we ran last time, and we're going to see how far we get. So let's go up here and let's draw out all the frames. And let's see what happens. Also, let me change it to a threshold, like this guy right here. Oh, that was an accident. And let's do this. Okay, right here. Let's go ahead and get rid of this guy. And now let's see what happens if we make it. Actually, let's write it first, and then let's make it. Okay, we got a whole bunch of errors. Let's go ahead and see what these errors are from. It looks to me like we got a lot of errors. Okay, so 20. Probably because we don't need a semicolon at the end there. Let's go ahead and clear. And then let's make again. Okay, that one made just fine. And it looked like it took, I don't know, I'd say a lot of iterations. So maybe we won't get to the end here. Okay, so let's see what we got. Delay animation.gif. And let me do Mirage frames animation.gif. Okay, here we are. We're drawing. And it looks just fine to me. So let's take a look at the images. So let's do this, and then we're going to say frame image. Let's do 00099.png. Oh, huh. Well, that's weird. Yeah, that's kind of weird. So let me see. What do we need to do then? It looks to me like actually we're set. If we go to frame animation.gif, it looks like the area is not overwriting itself, which is weird because I swear it was last time. Did I maybe not write it correctly? Let me see. What do we have here? Let's get back to the other image. Area 0, %error 0. Interesting. These all say area 0, %error 0. They don't even try. So I guess that was not the GIF that we needed. So let's go down to the bottom again. G. And let's remove all the 1024s that we just added in. just because I think that could be breaking something. So let's make sure this version works, and we'll go back to this in a second. Here we are. I guess I could... Nah, it's not worth it. Okay, that's fine. It's 5:20 in the morning, so we have plenty of time to get this done. No worries whatsoever on my part. Okay, so now what we need to do is change the way these boxes are drawn, because apparently they're not being drawn correctly. So let me think. It looks like... Where are we? We were right here. It looks to me... Let's see. So this guy right here is being put on 2020. That's fine. So it should be... We start at 0, 0. And we go to 20. That seems right to me. We are going across the entire, you know. Oh, you know what I forgot to do? Cairo rectangle here, and then I forgot to fill it. So how do we fill a rectangle with, with Cairo? Let's do Cairo example. Oh, shoot, I have it previously in the code. Why do I even look this up when I know I have it previously in the code? It is Cairo fill. Frame context. Okay, we're gonna go down to the bottom and let's see what happens. Again, guys, if you have any questions, comments, concerns, anything like that, let me know and I'll get to it as soon as I possibly can, or I see it in chat. Absolutely no problems there. So let's go here and let's put down this context. Okay, so now we're gonna do the same thing down one. Cut rectangle, and then we fill it. Oh. Oh. Okay, let's try making it one more time. And let's see what happens. Make. Give it a second to draw all the PNGs. Now we're going to run this guy. Okay, so this looks pretty good. The area is clearly being rewritten every time. It looks like everything's fine. Let's see what the GIF looks like. So let's do animation. 1 second. Mirage animation. .gif. Okay. We'll watch it over here on the side. Looks like it's fine. Let me see. Does it finish in time? That's the question. I don't think it will. Oh, maybe it will. Maybe, oh, wow. Look at that. It does. Fantastic. Now, is this the same one we had before? 7.17. Let me see on Twitter, because I know I posted it on Twitter. Let's see. James. And let's see what we got. So, last time it ended at 7.17 or something like that. But I think this one, I just want to make sure it's not the same one. Let me see. Oh, it is the same one. Shoot. That's unfortunate. Okay, so let's go back to the image here. And let's see, what do we have here? Oh, I bet you I know why. Yeah, it's because I didn't delete the last guys. Yeah, okay, that's fine. So let's go up here and let me do remove R. I'm sorry, just remove. What do I want? 1 second, frames. Star. Good. Now we're gonna do make one more time. Let me do make clean, and then make. And now let's see what happens. Okay. So this one will generate an actual simulation with the guy that we're working on here. So now let's do mirage animation.gif. And it doesn't work. Great. Oh, I know why. VI make file. Let's go here. And let's comment it back in. So now let's make. Let's... Hey, Clone Style, what's up? Yeah, everything's going perfectly fine today. Let's see. So I want to do make clean. And then make one more time. Okay, so give it a second to do its thing, and then we'll see what happens. It's converting it into a GIF, and... Almost there. I don't know how long this is going to take. Maybe I should check top. Ah, there we are. So now let's take a look at the animation. There we go. It's being drawn. 1 second. And I'll just kind of leave this up on the side as I'm doing the other stuff. Okay, so let's watch it for a second. It looks like it is doing everything we want it to do. It is the perfect simulation. We're good. Monte Carlo. Okay, so I did this at the start of stream, but if you see this GIF on the other side here, we're calculating an area at every single time step, and we're calculating a percent error. Monte Carlo is one of those things that it's like, to me, programming magic in a way, and I use it all the time. It's one of the most used simulations in physics and things like that. The idea is relatively simple. Again, I said this at the start of stream, but it bears repeating. If we're integrating, let's say here's an xy axis, and we draw a line, which corresponds to y equals x, okay? The integral of this is going to be x squared over 2, right? And we know this from basic mathematics, right? But if we think about it in another way, right? And we call this, pretend I can draw this x, and this x. No, you're perfectly fine. Then it's fairly obvious that this has to be x squared over 2 because this is the area of a triangle. Is x squared over 2, right? So these guys are the same thing because a triangle has the same base and height. Okay, so now let's think about this in another way. Let's think of it, instead of as a triangle, as a square. And in this square, we have a single line going from, oh, here, let's draw this another way. A single line going from here to there. Now this is clearly the same line we had before, y equals x. But in this case, we're thinking about it a little bit differently. Instead of thinking, okay, let's integrate x, we're thinking, okay, we have a box. And the box's area is x squared. Now we know that the area of the triangle must be 1/2 of that, because it fills exactly half of the space, right? And that's kind of the idea here, right? So we're asking, I love how computer fixes lines. Okay, yeah, I know, right? So the triangle area is going to be exactly 1/2 of the area of the box, and we know that just by looking at it. But now we have a question. If we have an arbitrary shape, where does this 1/2 come from, right? And that is a question Monte Carlo solves, right? So how does it solve this question? Well, first of all, the 1/2 is basically a ratio between the two areas. So if we redraw this, we could say that 1/2 is going to be the area of the triangle. And I'm going to draw it like this, just to save time. Never mind, I'm going to say triangle. Over the area of the box. And that's great, except if we're looking for the area of the triangle, we don't really have this guy, right? So what do we do instead? Well, we say, okay, well, the 1/2, maybe we can find it in another way. And the other way is by random sampling. It should be that the 1/2 is equal to the number of points that fall into the triangle versus... yeah, that's fine. I love Twitch. Thanks for doing that. I appreciate it. You're actually like super supportive. Like, of all of the followers, you post this so much more frequently than other people. And sometimes I get a little bit worried because, you know, like, some days I'm not really doing that much stuff, you know? Anyway, so through the power of random sampling, we go through and we can work on this a little bit differently. So here's what we have. If we do a whole bunch of random sampling, right, something like this, then, again, these are just random points. It should be that the number of points that fall in the triangle, oh gosh, if I can spell triangle, over the points total. 1 second, total. But 1 second, I want to make sure, for the record, I'm super appreciative. You know, like, it's not like I'm not appreciative. I'm just sometimes worried that my stuff isn't good enough to be shared on social media. That's what I mean. But I'm totally appreciative. So the points in the triangle over points total should also equal this 1/2 value. And that's what Monte Carlo does. We do random sampling in order to figure out how filled the exterior space is by the interior space. And this will give us the area that we're looking for. And that is kind of the neat trick here, right? It's something that you don't typically see in other algorithms. We're trying to find basically how filled the exterior region is. And this is, in essence, a, how do you put it? In essence, an integral because we're finding the area within this triangle via random sampling. And that's how Monte Carlo works. Now, obviously, because it's random sampling, you got to go 100,000 times before you actually see the sampling happen. So that's why over here what we're doing, one second, let me pop over to this desktop, is we are finding the area every single time step based on the ratio of the points in and outside of this circle, right? So the red are outside, the green are inside. We find the ratio, and then we multiply it by the area of the exterior box. We're asking how filled is this box? Well, it's filled by a certain percentage, and that percentage is how many are in versus how many are in the box total. Does that make sense? I'm hoping it kind of does. So again, the idea is that we're just continually doing the Monte Carlo, or we're continually putting new points into the box, and you'll see that our percent error is pretty low. You know, it's not as low as it could be. It's not below the threshold we set, but it's pretty low. And the area is pretty close to what it's supposed to be. In this case, because we have a radius of, I think, 125, it should be that the area is 49,000 or something like that. Yeah, I mean, that's true. I love Twitch. The thing is, this channel, right? So back when programming was a thing, right? The programming category, there were a lot more people who used to do a lot more things besides just game development. Now, I feel like there aren't as many, you know? And it's a little bit sad because we used to have a nice community going where people would develop a whole bunch of things. Now, Clone Style, he doesn't do game dev either. He does a pretty good stream. He usually comes on kind of late at night and stuff like that. So if you're interested in other streams like that, feel free to check out his channel because he does a whole bunch of cool stuff. Unfortunately, I don't really have time for that. Clone Style, when would this be used? This is used a lot of times. So for example, let's say we have an arbitrary shape inside of a known exterior box, right? So we know that we have a box and we have some sort of arbitrary shape on the inside, right? We cannot integrate the function by normal means. And the reason we can't is quite simply, right? If the function is, for example, the Batman function, let's go over to the Batman function, there's no way we could integrate this. Well, okay, we can integrate it analytically, actually. This one's not so bad, but not by typical means. You can't just run an integral or something like that. You've got to add up all the boxes and things like that. The Monte Carlo algorithm, on the other hand, will integrate it, right? You can integrate arbitrary and somewhat misbehaved functions. Yeah, it's any case where we don't have simple shapes or we have to do the integration numerically, Monte Carlo comes in handy. And that's because in order to, you typically need fewer points you need to ping, or you need fewer points with Monte Carlo than you would if you just did an arbitrarily small dx and did the same counting, right? So if you think about it that way, yeah, exactly right, Mary. And that's how it is. It's actually super cool. It's one of those things that to me, the first time I heard it was like programming magic. And that's why I wanted to make a YouTube video on it, because I know a lot of people use it. And I hope a lot of people find it interesting. I just think it's a lot of these algorithms, just when I look at them for the first time, I think they're so clever. And actually, there's a couple of other algorithms like that, like the Quantum Monte Carlo we did a while ago. Holy cow, that was so clever. Like, it took me a while to get it, but once I saw it, I was like, wow, this is amazing. You know, and a lot of other things. Every once in a while, I just see an algorithm and I think it's so cool. Okay, so let's see, what do we need to do now? Let's go through and let's see what we got. So we have print area and print percent error working. So now we're gonna do something a little bit different. Here, what we're gonna do is we're going to remove this entire section where we're drawing all the points and adding them up. And you might think to yourself, why are we doing that? That doesn't make any sense. Well, one second. So because now we don't have a background on the global image here, and I realize it doesn't look as good as the other one did, I think. I think the lines are a little bit more jagged and things like that. That's okay. That's okay. Let's go through and let's do it one more time. Except this time we're drawing the points here. And at the end of every time step, we're increasing the frame that we're at. So let's go here and let's see. Yep, because this only cares about points, or count, sorry about that. We can do it this way. So we're gonna say anim.current frame, which is again the current frame that we're on. and we do plus plus. Let's write this, and now let's go over here and let's make it one more time. First, let's get rid of that one. Make. Okay. Let me see. Monte Carlo segmentation fault. Never mind. I broke it. Let me do something real quick. Let's not do this. And now let's make it. This one makes just fine. Dang. 1 second. But it's going to do something stupid. So if we do this, wait for it. There we go. They're all up at the same time. And I don't like that. So what we want to do, let's see, anim current frame plus plus. I think I know the problem. The problem is that the simulation goes above the number of time frames available. So let's do, how do you generally feel about while loops? In general, I don't use them. However, in this case, I did. Yeah. So you're right. In general, I don't use them. For loops usually take the place, but that's okay. Right angle, best angle. What is the end goal here? I'll show you in just a second. Let's run the simulation. So we're going to do if, let's say, count is, wait, what are we going to do? Anim. Wait. We have to make sure we don't go over the number of frames allotted. So we need to basically say if anim.current frame plus 1. Yeah, that's what we're going to do. Current frame plus 1 is less than number of frames. Then we go here. Oh, sorry about that, guys. And we go here. Okay, so this should work then. We're going to write this, and let's do make. Give it a second to do its thing. Yep, okay, seems to work just fine. And now let's pull up the GIF in a second. And guys, I think, here's the thing. I don't know whether it's called GIF or GIF. I think the creator said GIF. A lot of people like GIF with a hard G. I guess it doesn't really matter that much. One thing I forgot to do here, guys, is I forgot to print the area. So let's go and let's print the area. Let's see. So we have print area here, and we have print % error there. So all I need to do is take this guy and copy it up here. Draw point, and also go here. And there. But in some cases, while loops make more intuitive sense. Yeah, people do say that if loops are almost always the preferred alternative, there's PBS videos on it. Really? Not sure. Okay, again, right angle, best angle. I'll get to you in just a second. I apologize for the wait here. So let's do area color. And I need area, I think, of count because of how I did it. Wait 1 second, let me see. I think maybe it's just temp area. There we go, that's what I need. Temp area, and then I want PE, and PE color without the S. Okay, let's go over here and make it one more time. And I think this one ended super early. So, give it a second to do its thing. It is making the GIF, and now let's do Mirage. Yeah, and it should end soon. Oh, maybe this one's good too. Okay, there we go. So this is what I want. So right angle, best angle. Here's what I want. I'm gonna take a look at this real quick, and then I'm gonna pause it. Oh, how about the GIF and GIF thing? It's a hard G. Yeah, I mean, you're right. Okay, anyway, right angle, best angle. Here's the idea. We have a situation where we are... How do I put this? We have a situation where we are generating... Wait a minute. I think I did something stupid here. Yeah, I totally did. Okay, let me go ahead and remove all of the images in the frames directory. Okay, now let's make it one more time. Make, clean, make. Okay, there we are. Good. And then we'll watch the video and see what happens. 1 second. Mirage. Okay, here we are. It's probably going to stop early. Let me see what happens. Are you gonna stop early? Come on. Do something. Okay, that's fine. It looks like it's doing what I want it to do. That's fine. That's perfect, actually. Okay, good. So it is doing what I want it to do. Yeah, Ibran, I totally agree. It's weird that the creator says GIF, but everyone else says GIF. Anyway, finally, right angle, best angle, let me tell you what we're doing. So this channel is exclusively devoted to, well, yeah, it is exclusively devoted to computational physics. By that I mean we do computational numerical physics algorithms all the time. One algorithm that we did a while ago was the quantum Monte Carlo algorithm. I want to introduce the quantum Monte Carlo algorithm on my YouTube channel, but I can't do that yet. And the reason I can't do that is because I haven't introduced normal Monte Carlo. And so this week what we're doing is we're taking a step back, introducing what normal Monte Carlo is, so that when we do quantum Monte Carlo, it's amazing. You know what I mean? Like, it's just one of those things that when people look at, they're going to be so just wowed by. Because it's one of those algorithms that when I saw it, I was wowed by it. Of course, normal Monte Carlo was the same way. And so the point is, what I want to do is I want to make physics, I want to make the programming fun. And so what I'm doing here is I'm generating basically this animation here, and I'm fixing it up. I'm making it look good, work well, things like that. I'm going to be doing that for the standard circles, squares, and things like that. But later I'll be doing it for other shapes as well. Hopefully including the Batman function starting tomorrow, but we'll see how far we get. I think it might take all week. I'm not sure how long this will take. After that, we'll be going back to the Huffman algorithm, which is also super fun, dealing with data compression and things like that. Eventually working our way into encoding, and then maybe some quantum computing and stuff again. We'll see how far we get. Anyway, there's a whole bunch of stuff to do, a whole bunch of algorithms to cover, and that's kind of the point of this channel. I just wanted to point it out because a lot of people think, I guess because when they see programmers on Twitch, they think that the programmers on Twitch are there to make something, right? Hey, Dirts. I guess I could pronounce it as double X Dirts, but that's fine. Thanks for coming in, man. This particular channel is not making a big overarching software thing, right? This particular channel does smaller scale simulations every roughly 2 weeks, you know? So we get stuff done and we work on it from there. So that's the idea. So yeah, and the other thing too, is if you have any questions about what we're doing, feel free to ask. Good. Thanks, Dirts. Because I do my best to answer things as soon as possible, with as good of an explanation as I can give. Now, there's a couple of things we need to do to fix this simulation up, and we'll worry about that in a bit. For now, let's go through and let's just continue working on this. So now what I want to do, guys, instead of drawing 1 point at a time, I want to draw first 1 point, then 2 points, then 4 points, then 8 points, then 16 points, then 32 points, so on and so forth, all the powers of 2, until we get to the point when we have 1024. And that's what I was going to start doing a second ago. So let's go up to the very top, and let's do it. So all these guys are now going to be generated with 1024 points in them. Where are we? All these vectors. So let's do 1024. Again, I apologize for doing this twice. And let's do it. I think this is going to be a lot of fun, guys. I don't know, but we'll see. 1024. And I'm just going to put, dang it. 1024. Now, one thing I want to point out is the text editor I'm using is Vim or VI. If I press a period, it does the last command for me. And the last command was inserting 1024 in parentheses. So this does exactly what I want it to do. Okay. So now I need an additional integer value. And this integer value is going to be, where have I defined all my ints? I have not defined any of my ints. So let's define another one here. And we're going to call it vector count. The number, the max number our vectors should count to. Okay, so we're going to say, what are we going to call, what did I say, vector count? Yeah, let's call it vector count. Cort. Let me see if I can spell this right. I totally misspelled it. Int vector. There we go. Done. Okay, so now we have a vector count, and we're going to set it equal to 1 for now. Okay, so now what we're going to do, a Monte Carlo simulation is to estimate pi? Well, this one can estimate pi. That's fine. For the record, guys, in case you guys are not aware, let me do page, new page before. This is how you can calculate pi for this particular simulation. Bob Ross did 911 pi r squared, just saved you so much time. Forehead, yeah, fair enough. Would you use Vim or VI for large 20-file programs? Gixer, when I have more than, I would say, 7 files, it does get a little bit cumbersome if I have to keep them all up at the same time. But I typically find that, for the most part, the number of files in the program isn't so important. What is important is how many I have to keep up at any given moment in time. And so I would typically, yes, use Vim or VI for large-scale projects like that. However, it's totally up to your own jurisdiction, right? So for me in particular, because I do a lot of work SSH'd onto other machines, it kind of makes sense for me to do it this way. However, if you have access to an IDE and you like using an IDE, do that. I have no preference. Okay, let me go ahead and explain this. So one thing that SQZNet just mentioned was that we can calculate pi. So estimating pi, gosh, if I can spell estimating pi with, and I'm just going to calculate it as MC. This is not exactly what we're doing, but this is very related to what we're doing. So like I said, the ratio that we're coming up with at 1/2 is a ratio of the areas. If we perfectly embed our circle inside of our square, so that our square looks like this, and our circle looks like, oh gosh, that. Pretend it's perfectly embedded into it. SSH into boxes, that's fine. Let's pretend we perfectly embedded this such that we have a line here and another line here, okay? Now, this means that the radius of the circle is going to be equal to 1/2 of the box length. So this means the area of the box is going to be 1/4 radius squared, okay? And the area of the circle is obviously pi r squared. Cancel out these guys. This means that the ratio, which is one area over the other area, is going to be, one second. The ratio is going to be equal to pi over 4 in our case. So if we multiply the ratio by 4, we get an estimate for pi. Now, this is cool. It is a good application for finding and estimating the value for pi, and we can do that. However, for this particular simulation, I've chosen not to do this because I didn't want to overly confuse people. You know, what I could do, if I wanted to, is I could do this math very quickly on a blackboard, and then after doing it very quickly on a blackboard, I could then introduce everything we need to introduce for this simulation, and then calculate pi with it. However, at this point, I just want to say, because this is kind of an obvious application, I just want to say Monte Carlo is for calculating area. And that's the point there. So anyway, that was what SQZNet was discussing, because again, I did not discuss that yet on this channel. Okay, so what do we need to do? We, again, want to generate more than one point at a time, but we want to do it in a way that it looks real, you know? So let's go down here. And what do we have? We have, let's see, we have count, and then we have the vector count, right? So we're only going to print out when the vector count is equal to a certain value. So here's all our draw points. So let's do this. If vector count, oh, how about if count, dang, how do I do this? I could keep track of previous count minus previous print count. Yep, this is totally good. Is less than vector count. Then we do the following. Oh gosh, this is ugly. I'm sorry about that. Let's go here. And let's just go ahead. Oh, how about I do it this way? Oh, sorry about that. Ah, dang it. That did differently than what I thought. I thought I pressed capital I, but apparently I did not. Oh my gosh, what am I doing? There, got it. If count equals limit, limit times 2. If count equals limit, limit times 2. Let me see, does that work? If count equals limit. And the limit. Yeah, then we still have to keep track of another variable, right? So that's fine. But I think either way will work. Because in this case, the idea too is that we only keep 1024 into all the vectors, right? Because the problem here is that at some point we're keeping too much data. Because in the end, we're going to be doing 100,000 points. Here we've done like 300, and it takes a while, right? Where are we? Down here. So we're doing 100,000 points, right? So we gotta keep track of that a little bit differently. If count equals limit, limit times 2. Let me think. Oh shoot. Oh good. Vector count equals 1. Okay, so obviously the first thing we need to do down here, or last thing we need to do in here, is exactly like what Mariang said. And let's go here and say limit times equals 2. Yes, it's 2, 4, 6, 8. Yeah, 1, 2, 4, 6, 8. But yeah, same thing. Yep. Good. Okay, so now what do we need to do? Let's see. We're gonna print area, and what we need is a quick loop in here. So we're gonna say for. How do I want to do this? I guess I'm gonna say for I equals 0. Am I already in I? I think I'm already in I. So let's do int j equals 0. J less than, what do we want? We probably want vector count. That's actually exactly what we want. Plus plus I. Go down here. All right, Dirt C round. Thanks so much for coming in. I guess you must be in Europe. Okay, so draw point, print area, good. So now what are we going to print out? We're going to print out, let me see. Bob Ross did 911 plus plus J. Yeah, you're right. Thanks. I thought you were going to bring up a discussion about post and pre-increment. Okay, good. I appreciate that. So draw point, animation, location, point color. So what I need to do, a little bit late, but thanks again. Location, print colors. So now what I need to do is I need to go in here and print out the area. Actually, no, temp area will stay. Now the location. That one's going to change. Let me see. What do we have here? Location of all of the points. So what I need to do then is down here, I need to put the print area and print % error. And the reason I want to put it down here is because there's no reason to continually redraw these. Because we're only drawing one frame, it doesn't really matter that much. Now, we also need to put this if statement up here. Okay, I apologize for being kind of messy with this. Good. Let's remove them from here. Okay, so this, in a way, is kind of working towards what we need to get done. So, what are we going to do? We have vector count. And then every time we go to vector count, we need to fix something. What do we need to fix? Well, we're going to say previous print count. I want to just call it PPC. I know that doesn't make any sense, but anyway, we still got an hour left until the channel ends, so we got plenty of time. So let's go here and let's say previous print count equals count. Oh, that was meant to be a semicolon. Somehow I hit an equal sign. All right, let me go up here, change an integer. Where are we? Integer. Here we are. Vector count and previous print count. Print count is going to be equal to 0. Okay, so now we have to fix everything up. What does that mean? Well, I don't know. Let's do it. Okay, so these guys only have 1,024 elements in it. And let me go down and make sure that our little loop in here does exactly what we want it to do. So previous print count here, limit equals times equals 2. And we're going to say if limit is less than 1024, we do the following. Bogsakma, I hope I pronounced that right. I'm using Arch Linux. Again, Linux distributions for me, I don't care. You're right. Let's go to the top. Monte Carlo. Yep, that's me being stupid. Previous print count. So yeah, as far as Linux distributions are concerned, I've used a whole bunch of different distributions. Personally, I don't care that much what distribution people use. When it comes to Linux, I really and truly feel like if you use it for programming and you're good with it for programming, that's all that matters. You know, so just use what you're good with. If you're good with Windows, use Windows. If you're good with Mac, use Mac. For me, I just chose Arch Linux because it was the first distribution I learned, and I like it a good bit. So that's, I know a lot, Arch Linux has a negative stigma in the community as a group of people who constantly put people down. I know that's, for me, I've never had that experience, but I guess a lot of other people do. So just keep that in mind. Distribution, in my opinion, doesn't matter that much. Of course, I'm pretty relaxed when it comes to this kind of stuff. I don't really have too many religious wars, if that makes sense. Okay, so print %error for J. I think this should be fine then. Good. Okay, so now what are we going to do? We are going to not sure. Okay, so here's what we need to do. We need to go through, and now every time we push back, we need to do this a little bit differently. So instead of pushing back, we need to do it this way. So let me go up to the very first push back. And again, the reason I was doing the pushing back was because before we had this thing where we said, well, while we are greater than threshold, now because we're thinking about this in a different way, we need to think about everything else in a different way. So let's look for the pushbacks here. So now all of these guys are going to be changed. I'm going to leave the pushback version up, and then I'm going to rewrite it. So we're going to say points of the count that we're on, which is going to be count minus previous vector count is going to be equal to points plural, my bad, location. Okay, now we go here and we basically do the same thing we just did. So 1 2 3 4 comment that in, then we say point colors PT colors. See, I'm just very bad with naming, gosh darn it. Anyway, let's do count minus previous vector count equals location. Oh, point color. Jeez, what am I doing with my life? Obviously not anything. Okay, temporary area is fine. Now this guy, we need to do area of, what do we want? Count minus previous vector count. Okay. And this is going to be equal to, what do we want? Well, we want it to be equal to temp area. Good. Next pushback should be there. So now we're going to say PE vector. And again, naming is quite bad here, I understand. Is count minus previous vector count. And guys, let me know if you can hear the air conditioning. It's kind of hot here in Okinawa, so I have it set actually arbitrarily low. It's 26 right now. I guess I could change the value, but that's okay. We're going to put in absolute value of the %error. Okay. Now, the next pushback, we only have a few others left, are area colors and %error colors. And here's the thing, I'm just thinking about this right now. Thanks, Mariang, for letting me know. I'm actually thinking about this right now. And I honestly feel like we don't need area colors or push colors. It's fine. That's fine too. I mean, truth be told, it's fine. Can't hear it? OMG scoots. For the record, guys, I'm using IRSSI, so it's always funny when people use emotes. I don't think we need point colors, nor do I think we need area. So I think what I can do here is I think I can get rid of this guy, and this guy, and this guy. Now, these guys I can also get rid of. So period. Okay, so when we compile this, it's going to give us a whole bunch of errors and warnings, and that's fine. The warnings should be fine. So let's go over here to make. Previous vector count was not declared in this scope. Let's see what we got here. 350. Limit was not... What? I wrote down limit? Oh, that's vector count. Let's go here. Okay, and then we say 350. Okay, so the problem is that that's not recognized, and it could be for a number of reasons. But let's go up here. Previous. That's because I call it previous print count. Okay, so let's go through and fix all that. So let's go :s previous vector count with previous print count. Okay, G. That should be fixed. Let's write this and let's go to make. Okay, this one seemed to make, but then it seemed to break. So let's see where it's breaking. We got to... what I want to do now is every time we print out this, I also want to print out the iteration that we get to. And we're going to see how far we get. Oh, actually. Yeah, okay, that's fine, that's fine. So where are we couting? We're couting temporary area, and let's also print out count. Tab. Okay, let's go ahead and write this, go over here, and make it one more time. Okay, so we're getting to 7,250, and then it's breaking. So let's see, is that... let's also print out then one more thing, because why not? So we're going to print out previous print count. Actually, let's print out vector count. Tab, and also previous print count. Tab. Okay, let's move these on to the next line just to make it a little bit easier to read. And let's add some guys in here. Oh no, we're gonna have to do it again. So let's move this down here. There. Now let's do make. And let's see what we got. So previous print count is 1. Previous vector count is 0. Okay, so I think I kind of see what's happening here. Let me see. Where are we? We are... I'm sorry, SQZNet. I can't help with that, but, you know. Okay, so count minus previous print count is less than vector count. Why is it zeros and ones? Let's scroll up a little bit. Is it always zeros and ones? It looks like it's always zeros and ones, so far as we can see. So, what does that mean? It means... I have no idea. So, the vector count should not be 1 in this case. And the previous print count should not be 0. This means that we're never printing, which means count minus previous print count is never less than vector count, which is fine. Vector count is 1. Count. Does count start at 1? Where does count start at? Count equals 0. Aha, okay, I see the problem here. Then let's say less than or equal to. Now let's try making it. This one seems to be doing its thing. Yeah, okay, this is fine. Okay, we'll let it do its, you know, its guy. I don't know how long this is going to take, and I don't actually know what's happening here. But it seems to be running. Just fine. I guess it's going to continue running till we're at 100,000, right? Huh. This might take some time. Yep, this is definitely going to take some time, considering we're only at 10,000 now. You know, it's hard to parallelize this. I'm trying to think of ways in which we could do it. There are a couple of ways. Let's change this a little bit, because that's taking too long. Let's go up here, and let's change this while from 100,000 to, let's say, just 1,000. Okay? Just to make sure it's working. Okay. And let's see what we got here. When are we printing out? Count was the first one. Let's go here. Let's do make. Okay, so this is only going to go to 1,000, so it should end right about now. And then we're printing out all the frames. It should only print up to 300 frames. So let's see what we got. 1 second. Give it a second to put it into a GIF. And then let's check the last Mirage. We draw that. We are putting out all the points. I'm not sure if this is working or not. So let's go through each individual frame. So let's do... It probably is broken though, you're right. So let's do frames and then image. Let's just start at the very beginning. Here's the first image, nothing in it. We're drawing a square, drawing a circle, and we draw exactly 1 point. Another point, another point. Okay, this is still drawing just 1 point each. It should be drawing more than 1 point each. Okay, and I see the problem then. We should be printing out, instead of location, we should be printing out a couple of different guys here. So let's do, instead of location, it should be whatever I called it. But I don't remember what I called it. So let's see. In circle, location X, box dist, if in circle. Nope, that's not what I need. What do I need? Point color, location X, location Y, points. That's what I need. So we want points of J. And then we also need point colors, plural, of J. Okay, let's try it one more time. Make, and let's see what happens. It gave us a warning at the very start saying that something was unused, I bet. So we'll see what happens. Give it a second to make the animation. And I'm going to need another quick sip of water. So let's go ahead and look at the animation while I do that. It's completely broken. SQZNet. I went to Okinawa. This happens a lot. Sorry, my voice is leaving me. But a lot of people ask questions about why I went to Okinawa. I am at the Okinawa Institute of Science and Technology, if you're interested. I think it's down in the description. But basically, I was in the US. I went to a university in Alabama. That's where I came from. I'm pretty good at research. I'm not the best at it by any means, but I'm okay. I'd say I'm at a moderate level. And then basically I applied to a whole bunch of places. One of the places happened to be OIST. They flew me out here. It's a beautiful campus filled with absolutely amazing people. And I had an opportunity to come to Okinawa. And I said, hey, you know, how many times am I going to get the chance to live in another country for 5 years, fully paid? I couldn't think of very many other better opportunities for me. So I said I would do it. And now I'm here. I'm learning Japanese, although I'm quite bad at it right now. But this institution is completely English speaking. So that's kind of for the best. Anyway, just wanted to point it out. The reason I went to Okinawa is simply because it was the most interesting thing I could have done at the time. Now, let's go and see where we're drawing all these points. So what I'm going to do is I'm going to go here and I'm going to print out points in J. So let's do std cout. Follow OIST Twitter to see his amazing stuff. Yep. I'm sorry. Do they think you're a soldier there? No, because I have long hair. That's actually why I keep my hair kind of long while I'm here. I was thinking about cutting it short, but then I realized I'm clearly not of Asian complexion. And so if I have very short hair and I present myself in a particular way, I will be seen as a member of some sort of American base, and I definitely did not want that to happen, because quite frankly, a lot of people in the American bases are, they do things that I do not necessarily appreciate. Not all of them. Obviously, I'm majorly, like, let me say it this way. A lot of things have happened that I do not appreciate in terms of American occupation, I suppose, of Okinawa. I mean, they aren't really occupying Okinawa, but there's a lot of things here that I don't necessarily agree with that the U.S. has done. However, that doesn't mean that everyone's dumb. It just means a few people. And the Americans do have a negative stigma in Japan, or in Okinawa. So, are you the only one that can see the signal still? I'm not sure what you mean. Sorry about that. Am I still up? Let me check. Am I still up? Yeah, it looks like I'm still up. Good. Okay, so now what do we need to do? We are C-outing some stuff here. We're C-outing points of J. Let's do points of J dot X and tab points of J dot Y. Let's do points of J dot Y and line. Okay, so now let's go up here. Let's actually see out this guy down here, not see out this guy down here. And let's do it this way, because it's a little bit easier. So let's do quick make, and let's see what happens. So they're all 0, which is great. That means we have something to fix. We understand you don't want to be associated with a certain group of people. Lucky. I'll try to see if I can somehow reset mine. Thanks. Oh. SQZnet. I didn't realize that you weren't able to see the stream, but it seems fine. It is up, I think. Okay, so these are all 0, which makes sense why we were visualizing nothing. So now let's see if we can get this to work. Woo. Okay, so now let's see if we can get this to work. What do we need to do? First of all, for some reason, points is not being updated to the appropriate location. So what I want to try is the following. Oh, my bad. Let me print out this character every single time. So let's print it out up here instead of printing it out down here. And let's see if we can figure out why it's breaking. And let's see, it's 6:12 in the morning. Again, guys, we still have another 45 minutes or so until I typically end the stream. So we'll see how far we get. So we're going to go to STD. I'm going to print out the same thing. So let's copy the same thing. And this is, instead of going to be J, it's going to be count minus previous print count. Here. Good. And same thing here. Now I should fix it for formatting. I always do. So let's go here. And let's bring it over here. Okay, so now let's do, real quick, make, and let's see what we got. Temp area. Yep, that makes sense. Okay, let's make it again. Okay, so this one is clearly outputting things. In fact, yeah, it's clearly outputting things. So let's also print out, along with this, one more thing. And that other thing that we're going to print out is going to be count minus previous print count. Okay, then a tab. And then we'll bring this down to the next line. Right? Make. Okay, so this is always 1. Which I guess would make sense. So let's see what we got then. If this is always 1, why is it always 1? Let's see, count minus previous print count. So, do we ever get into this loop? Let's see. Let's go here, and let's do stdc out printing. And line. I'm pretty sure we do get into this loop because we did a second ago. Make printing, printing, printing every time step. Whoa, that's a little weird. Where should the count increase? The count increases up here on the exterior, right? So it's going to count minus previous count. So it looks like count minus previous print count Let me see. Previous print count equals count. So let's see. Let's just kind of go through this real quick. So we have count minus previous print count less than vector count. So vector count is going to be equal to 1. Okay? Oh, wait a minute. Less than vector count. Maybe we should do this as equals vector count. So let's now do make. I don't know what just happened. So let's see. Up here a little bit. We apparently went through, let me see, printing. Is that right? Printing at 256. Good. At 128. Okay, it looks like we're actually doing what I want to do now. So let's do the last mirage, which is the animation. 1, 2, 3, 4. Okay, so now we're drawing points. Okay, they're all black, but I feel like they might be working. Okay, so 1 point. Oh, 3 points. Oh, these are all different points every time. Shoot, we need to keep the previous points. Why are we not keeping the previous points? Last time we were keeping the previous points. Okay, let's see. Why are we not keeping the previous one? And why are the colors not right? Point colors should totally be updating too. Where's point colors? Point color RGB. Let me see. This means that the point colors are always, let me see, point colors push back. Oh, that's because I'm an idiot. And let's do this. I deleted it a second ago. Point colors. Then what do we want? We want point colors of count minus previous print count equals point color. Okay, let's write this. Let's make it one more time and let's see what happens. Okay, so now I'm gonna watch the animation this time because the animation's a little bit more clear as to what's happening. 1 second. So now we're gonna do animation.gif. Okay, so I don't know if you saw that or not, but let's wait a second. Actually, in fact, since we're only going up to 1,000. Okay, so this is kind of doing what I want it to do, but not quite. So let me increase this to 10,000. And now let's do make. Give it a second to do its thing. Oh, never mind, it broke. Holy cow, why did it break? We got to a certain point, and then we got an invalid pointer. Let me see. This would mean we're probably going over the bounds that were allowed. Okay, that's fine. So I guess this means, let's see, so what are we printing out here? We're printing out count minus previous count, 786. Yep, that's fine, 1024. So it looks to me like that should be fine, 785. So we're trying to print out 786, right? Interesting. Let's try making it again. Yeah, it still broke again. And it broke at the exact same point, presumably. So what's happening here? Initializing. Count minus previous count. Well, we're not yet at the point where we'd enter the printing loop, right? Here is printing. So we're not yet at that point. Yeah, so we're not yet printing. Let me see. Could it be that we finish? Let me think. Why does it stop at 1024? It's just, I wanted it to be constant at some point. So I wanted it to increase up to 1024 and then plot 1024 every time step. That's just kind of what I wanted. It was more of a design choice than anything else. Okay. Well, this could be done for a number of reasons. So let's go down and let's see. The first thing I want to try adding in. This loop makes me nervous. Sorry. Okay. So let's do it a different way then. Let's change the while loop to a for loop. What if you don't have 1022? That's what I'm thinking is probably broken. The fact that we don't have 1024 points to draw. But I'm thinking here, and that shouldn't matter, right? I don't think so anyway. So here's what I want to do. I want to print out something here. And let's see, we're already printing this out, right? And so I presume it's breaking down here somewhere. So let's go here, and let's print out end of loop. Let me see. Actually, let's just print this out. This will tell us that we're at the end of the loop, right here, and let's make. Okay, it breaks. Let's see, so we get to the end of this loop, which is at the end. Yep, so you guys are totally right. We get to the end of the loop, and then it doesn't exit correctly. Or something. What's next? There's absolutely nothing next in this function. Everything else is commented out. So, we get to the end, and the loop exits. Then after the loop exits, I'm not sure. I'm not sure at all why it would break at that point. So here's what I'm going to do. I'm going to go up here, and instead of doing count plus plus there, I'm going to do the following. So change this while loop to a for loop. For count, let's say, I think we've already defined count, but we'll do int count equals 1, because we've already defined it all to be 1. Count is less than the iteration we want to get to, so let's say 10,000. Then plus plus count. Okay, then up here. Yep, you're totally right, Mariang. You are totally right. So let's go down to count here. And let's write this. Now let's make it one more time. Yeah. Okay, so now my question is, why is it breaking? I'm not sure why. So we get to the end here. Right, we get to the end here. The end of the loop. Oh, the loop is actually ending up here. We get to the end of the loop. Why would it break? I don't fully understand. Let me print something out down here. One second. Okay, now we do make again. Let's see how far we got. Yeah, okay. So it's having a problem for some reason after this is done. So let's go up to the top then. And we do draw frames. I think if we don't draw the frames... Yeah, we'll see. So let's not draw frames. Let's go here and let's do make. Anim.draw frames. 1 second. What did I just do? 106. Oh, I see the problem. That was not the main function. Question mark main. Now we're gonna not draw frames. Let's do make. Okay. So this one still breaks. You had a condition where you set the limit to 1024. Yep. Okay, yeah, so let's just do it that way then. So let's do... let me see. Where are we? Animate square. No, I want to go down to Monte Carlo. Okay, so we're right here. The while loop then. I don't see why it would give me an error though. Like, there's a lot of times. We basically have a few... Let me see. So it might crash at the end because of an out of bounds right. The memory deallocation scope exit. But... Okay, so how about this then? Okay, so let's print out a couple of different guys here. Let me see, what do we have? Invalid pointer. I guess I just don't understand, because this just means we have elements inside of some of our vectors, right? But that shouldn't matter, Should it? Is it a big deal to have... No, it shouldn't be a big deal at all. Let me see. Because if this is less than... Let me see. So if this is only 1,000, it works just fine. Make. Yeah, and this is the same issue we had before. So let's go up here. Where are we? Let me see. Where's main? Okay. Anyway, draw frames. Let's go down here. Let's make it one more time. Okay, yeah, this one makes just fine. And it's clearly terminating at 1,000. So why is it such a big deal to terminate elsewhere? I guess I'm just not understanding that one little thing. Okay. I mean, for now, it is working with what we have right now. So let me check the PNGs we have. Mirage. Let's do frames. And then we do image 0, 0. Okay, so here's us drawing the box. Here's us drawing the circle. 1 point. 1 point out. 1 second. 3 points. Let's see, 1 point. 3 points. Let me see. 1 second. The next is going to be 1, 2, 3, 4, 5, 6 points. But see, they're all at different locations. And that's the thing. It shouldn't be at different locations. I don't understand what exactly is happening here. Let me see. And I don't know why we aren't keeping the previous frames. Because before, when we would just print the count, we would totally keep the previous frames. But now we're not. Interesting. Okay. So let's go here and let's see if we can figure it out. So there's a couple issues here. The first is that we're not keeping the previous point, right? So if you remember when we just drew the point, right? Every iteration, we just drew the point. It wasn't a big deal, right? We could... In fact, let's do it that way. So let's take this whole if statement out just to make sure I'm not an idiot here. And let's do this here. 1 second. And let me just print the points. So let's do, what am I doing? Draw point of anim, and then I want location and point color. Okay. So now let's do make. This one's gonna break, I bet. Oh no, this one works just fine. And let me take a look at the animation once it's up. So let's do animation. And this one should... Oh, wait a minute. What? Oh, I bet you it's because I didn't. Okay, let's go here and say anim, this guy. Oops. 1 second. Now let's go here and let's do make one more time. And then we'll watch the animation. And it should, I think, work just fine. 1 second. Mirage animation dot graphics interchange format. Yeah, so see, the points are being kept, right? So even though we're only printing a single point, all of the points are being kept. Okay, so now let's see if we can figure out how to change this around. Okay, for int j equals 0, j less than vector count plus j. We're drawing a point of all of the points and all the point colors. Okay? This is of course just one of the two issues, but I think that should be okay. So if count minus previous print count is equal to vector count, which means we're on a point where we need to print, we will print. Now, why would it be erasing everything we just wrote? Oh my gosh, it's not erasing everything we just wrote. Gosh darn it, I'm an idiot. Here, let's go into these images here. So let's go into Mirage, image, I'm sorry, frames, image, 0, whatever PNG. Okay, so we scroll down a little bit, and look, these are only going to have 1 point each. They all only have 1 point each. I'm an idiot. They all have 1 point each. Okay, we're good. So let's keep up this guy then. And now let's think about how to fix it from here. Okay, so we have this. Now, what do we need to do next? The next thing we need to do is get rid of... actually, let's just comment this little section out to leave it there. The thing... I'm not being very clear. Why do you have a percent error color? The percent error color was for something a little bit later on. We will look into it in a bit. Oh, are you saying because it's the same as area color? Fair enough. At some point I thought I wanted to color them different colors. Okay, so now let's see if we can figure out this last error. And this last error is the one that it breaks at some random point. Now, we know what the random point is. The problem is the loop is not exiting correctly. So, here's what I'm going to do. I'm going to change the way I want to generate these, the end of the while loop. And we're going to see if this works this way. So, I'm going to create a quick loop up here. We're going to say for, and let's just say int, why not I equals 0, I less than, what do we want here? Let's say iteration. That's fine. Then we're going to do plus plus I. And let's say iterations equals 20. Why not? Okay. 1 second, I need an int. And here's what we're going to say. We're going to say that this guy is going to be a number of generations to work with. Okay, so let's go here and let's say, what do I want? I want, let's also create int final count. And I could put them on the same line, but who cares? And we're going to set this equal to 1. Now we're going to say final count equals final count times equals 2. Okay, so this ensures that we'll end on the appropriate point. But let me do something real quick. We're going to say if the final count is less than 1024, we go here and we do this. Else, the final count, 1 second, final count plus equals 1024. Okay, now instead of going to 1000, we're going to go to final count. Okay, so this should make it so we're always printing the exact number of points that we have left. I think. Because we're getting done with the loop. It's just weird. Anyway, so let's go here. Let's exit that and let's make. Okay, so this is still breaking, and it's breaking at oh, it's saying it's printing. Loop finished. And then it breaks again. Okay, so this is where I wish I knew more about GDB. Okay, so let's see. We're clearly not getting back to main. Let me see. We're in main. Let's go ahead and print out std cout Monte Carlo complete. Make. Yeah, okay, so it's clearly in the ending here. So let's go down to Monte Carlo again. Nope. Here it is. Okay, draw point. Now why would it work under 1,000 but not work over 1,000? That I'm not sure. So we're printing. The loop finishes. So we are actually done with this loop. We are down here. And then for some reason at the end there, it breaks. Are we returning anything? No, it's void. That should be fine. Let me see. Let's print out anim.current anim.current frame. Make. Okay, the frame is going to be 39. That's not a big deal. Okay. None of this stuff is done. That's not done. Let's go down here and see if we print out more information, if it helps us any. Let's go to make. Okay. So what do we have here? It is printing. We are at iteration 11,263. Okay. 1,024. That's going to be the vector count, which is exactly what it should be. 11,1263 is going to be the previous print count. That's fair because we just printed. Then we want temporary area. That's fine. And percent error is fine. Note, just a quick note, the percent error is super low here. It's 10 to the negative 6. That's fantastic. That's what we want to see. Okay. So then, I don't know what's happening. I have absolutely no idea. For some reason, this thing is just breaking at the output. So let me try this again with a smaller number of generations. Instead of doing, let's say, what did I say before? 20? Let's just do 10. Yeah, just 10. Right? Make. Yeah, so 10 works. 15. I know this is a really stupid way to do it. Make. That one doesn't work. What is this at? This is at 6,143. Does not work. Let's try 14. That's about 5,000. Does that help, Marrying? Or did you need exactly 9,000? Let me see. 5119 doesn't work. Let's try 13. Make. Okay. 4094 doesn't work. 12. Make. 3071. Make. Let's see, 2047. Make. This one clearly worked, and it is at 1024. Okay, so this says to me that... There we are. Okay, so 1024 is the last one that will work on. So, let me think. Why would that be an issue? No idea, actually. So let's go through and let's see. So, we're probably over-allocating something here. So count minus previous print count. Are we ever printing that out? SD count minus previous print count. We are. So this should be 512. Okay. So why don't we do... Is 512 allowed? Or does it only go up to 511? Yeah. Let's try something. So let's do, instead of count minus previous print count, let's add a -1 in there and see what happens. So let's do -1. Okay, -1 in here too. Right, let's do make. Well, clearly that one works. That one worked before. Let's try 11. Where are we? What am I doing with my life? Oh, up here. Let's try 11. Final count 1024. 11. 11 didn't work before. Yeah, it works now. Fantastic. Good. Okay. Now what are we doing? Let's try 20. Make. Yeah, it's working. Fantastic. Okay, so let's check the animation. Hopefully it looks good. Come on. Okay, so we're gonna check the animation. So let's do Mirage. And what do we have? Here's a drawing. Look at that, guys. Fantastic. Good. It just sits there a while, though. Thanks, Abdel. Fantastic. Okay, so what am I going to do now? What I'm going to do now is... let's change this up a little bit. So let's do... let me see. How far did this get to? What was the final count? The final count was 11,263. Is that what we need? Probably. But let's increase this to, I don't know, 30. And let's do make. And then give it a second to do the thing. Okay. And then, guys, I'm going to go ahead and commit this to GitHub once I'm confident it works. So let's do this. What is it? Mirage animation.gif. Yeah, okay, so it works just fine. But let me think. What number did we just get to there? We just got to 21,503. So these iterations, that's going to be the number of frames, essentially, that we go through, which is great. That means that we can actually tell the number of frames. This actually, I like this, because this will also give us, so this, for example, will be a 3-second Monte Carlo guy if it's 10 FPS. So how about we do, how about when we get here, we lower the line width. So here, let's do, what am I doing? Every time we write out, draw a point, let's also lower the line width here. So Cairo set, Cairo line 2. So let's go up here and change the line width to be a little bit lower. And the reason I want to do this is because, where's set line width? Here it is. This will make it a little bit more obvious that we're adding points every time. So where is draw point? Draw point is there. Let's go here and let's do set line width, and let's just set it to 1 pixel. Okay, so now let's do, let's go down here. The number of iterations, let's set to, I don't know, let's set it to 50. And let's remove some of the unnecessary STDC outs. Just because they're unnecessary. Okay. Let's go down here to the last C out here. And let's do it. Oh, oops. My bad. Okay, so now let's do make one more time. Error. 285. Betcha for what? 285 frame. Oh, that's because it's anim.frame context. Frame context of the current frame. There we go. Write this, go over here, make, and let's see what happens. Okay, so we forgot to see out. That's fine. Okay, now let's take a look at the graphics interchange format file. Once it's up, Mirage animation.gif. Yeah, that looks pretty. Look at that. That's great. Okay, now let's see what number we got to. So what I want to do, maybe it'd be worthwhile to also print out the iteration that we're currently on. We'll worry about that in a second. So for now, let's not output some stuff that we don't need to output. Print, let's see, PE? Yeah, that's okay. So let me do it this way. Where are we? Print area. Yeah, maybe I should also have print iteration. So let's keep that GIF up for a second. Because I could probably put I equals right here and no one would care. I think that's probably worth putting in there. Okay, so let's go here. And let's remove all these unnecessary lines because they are unnecessary. And did I have them on Git? I don't remember. But that's okay. That's okay. So next, that's unnecessary. Printing here. Let's get rid of this. Okay, and now let me just std cout one thing. Std cout count. End line. Okay, so as you can see, our Monte Carlo simulation is working. It's now a matter of adding in a few more things to make it a little bit more readable. For example, the area would be nice if it said pi r squared or something like that, so that it'd be easier to read what the area is supposed to be. Okay, so let's do make one more time. And let's see, what iteration do we get to? We get to 41,938. So let's add another 50 frames. Let me see, where are we? 50 frames, so let's make this 100. And that should be fine. So now let's do make. Okay, and let's see what we got to. We got to almost exactly 100,000. And let's see what happens. 1 second. This is actually pretty cool. I'm glad this happened the way it did. Okay, so let's move this over here. Good. Looks good to me. And you'll notice the percent error keeps getting lower and lower and lower here. But it doesn't quite get to... it's a lot. Yeah, it is a lot. And I feel like maybe we have too many points here. Because we don't get it under the threshold I want to get it to. Let's make it 200. So let's do make. There we are. Yes, I reached 1024 and 10. Yep. Okay, 1 second. It's making its thing. Mirage animation.gif. Okay, what do we have here? It is almost there. What did I set the threshold to? I don't know what I set the threshold to, but I feel like I set it kind of arbitrarily low. Yeah, 20,000 points sounds about right. Let me see, what do we have here? Animate circle. I did set it arbitrarily low. Let's do this. And let's make it one more time. Yeah, there are roughly 20,000 points in here. 1 second. Give it a second to make its animation. Okay, then we're going to do Mirage animation.gif and see what we got. Well, there we go. That's kind of nice. Good. That looks okay. I like that. I think that looks cool. Yeah. I'm happy with that. In fact, we don't even have to draw the square in the circle. Let's go over here. You can clearly tell the shapes. Is it based on the percent error? The area is changing color here. You'll see. Let's make it one more time. The area, if it's inside of the circle, it's green. If it's not inside of the circle, it's red. That's just the color choice I chose. Give it a second to make. And then we're gonna take a look. Good. Oh, yeah, the text is based on the percent error. So if the percent error is low enough, under the threshold that we set, then it will be green. If it's above the threshold, then it is red. And so basically it's asking, is this a good estimate? And the answer is sure, yeah. So the last thing I need to do is add in an I equals, like how many points we're actually plotting. But I think it looks pretty good. I like this. Okay. So at this point, I'm going to go ahead and right quit and do git commit Monte Carlo visualization.cpp. Did I change the make file? Let me do a git status. That was probably not the best idea. Modified Monte Carlo visualization, but it doesn't look like I modified anything else. I have so many files I need to modify in here, or I have modified, but I haven't updated yet. So let's do git commit Monte Carlo visualization.cpp, and let's say, man, this is such a messy directory. Anyway, let's say added new point creation scheme for Monte Carlo. Okay, right quit. And then we're going to do git push. Oh, wow. I haven't updated in a while. Origin master. Sorry about that, guys. Okay, so now the code is available on github.com. I will show you where to find it. And we'll go from there. So this code is available. Let's see. Let me go to my channel. Scroll down to info. Down at the very bottom. And it will be available on github.com right here. And it should be under Simuleos. It will be under the Monte Carlo directory, so it's going to be under visualization, Monte Carlo viz.cpp, and here's a file that we've worked on. Again, it uses a Cairo library, so I would suggest using the make file that I have also provided that uses the Cairo library to build the package. Good. Okay, so if you're interested, that's what we have there. Right now the Monte Carlo thing seems to be working okay, which is great. I'm very happy with that. Now we've got a couple of other things we need to add in. So let's go ahead and work on the next bit, which is going to be, let's see, Monte Carlo visualization.cpp. Yes, that's what I want. So let's go down here and let's add an additional guide, which is print count. Where we is Batman, print this, and let's do print function to write the count on upper right. I think this should work okay. Yeah, this should be okay, I think. Okay, so it's going to be void print count. And we need basically the same thing we had before. Animation, double percent error, and color. Except in this case, instead of percent error, we want count. In this case, the color is, in my opinion, should always be white. So we will not be reading in color, and we'll see what this looks like. So let's go down and create the function. It's gonna be down here. And let's see, print PE. Yeah, we'll put it after print PE. Okay, it's gonna be basically the same function, so let's just read in that function and modify that. Okay. So the first thing we notice is that we probably don't need the black box underneath the percent error. So we can go ahead and remove this guy. Okay. String, percent error text, this will be count text. And number, which will also be read in. And actually this should probably be an integer because it is count. Let's go up to the top and let's look up print count. Okay. Right here. So this is going to be an integer. And I think we can get this done before the end of the day. So again, in a couple minutes here, we'll probably be finishing up. So print count, let's see, st string, where are we? Let's see, PE, so this is going to be count again. Okay, percent error, and we want it to be count. Ooh, wow, I screwed that one up, didn't I? Okay, and everything else starts with a capital letter, so we'll start that with a capital letter 2. Now, what did I call number? I said number is going to be, yes, set with 3. However, I don't want to do it that way. No, this time I want to do it a little bit differently. So instead of the set with thing, let's see. I guess I could do it that way. So let's set with, let's see, if we're getting up to 100,000, that's 100, 100, 1, 2, 3. So that sees, I think set with 6 should be okay. Okay, now we do STC out. No, we don't need to see that out. Cairo source RGB, we want this to be white. So we're going to set it to, is it 111 or 000? I always forget. I'm going to guess 111. And hopefully that's right. Okay, color extents. So this guy's going to be, instead of at x equals 20, it's going to be nm.res x divided by 2. And then we do down here count text. All right, let me make sure I didn't accidentally leave any PEs in here. Upper right. Yes, so count text. Next. Count text. Next. Good, okay. So now let's go back to the previous guy. Where are we? Count. Okay, so now we have count text. So now what I want to do is up here in the top, or up here in the Monte Carlo function, when we write the text out, let's see, here it is, previous print count, print area, print PE. I also want to print count. So let's go here, and let's say print count. And what do I want? I want anim, and I want count. So let's see what happens if we run this. Write this, go over here to the side, and let's do, very quickly, make. It's gonna break. Okay, that's because I need to do 513. Why is the error negative? 1 second. The error is negative because of how I did it, but it shouldn't be negative. I don't think it ever goes negative. So the percent error is the standard. Yeah, thanks, Maryang. Error count, I also printed it wrong in 524. 1 second, 524. Count. Okay, now let's write this. Let's go over here and let's make it one more time. And let's see what it looks like. So this is about 200,000 points. And let's see. 1 second. Dang it, I put count in the wrong spot. Oops. You'll see in a second what I mean. But I still want to look at this GIF anyway. Yeah, see, the count is in the exact wrong spot. It should be up top. Okay, let's change that. So move to, I don't want it to be animation.y, I want it to be 20. Because I think that's what I did for the, yeah, 20. So let's go here and let's do make. Okay, and let's see what happens. And after this, we should be basically done with this particular section. Then we've got a couple more days left before we're done with Monte Carlo, and that'll be it for the Monte Carlo stuff. Yeah. So let's see. Oh, the percent error is negative, isn't it? Okay, that's fine. Let me fix that. So up here, where are we doing this? It should be the absolute value of percent error. All that means is that we're under the value. So let me do this real quick. Absolute value of percent error. Never mind, let me not do it because apparently I can't type. Write this, go over to make, and let's see what happens. Okay, now once we check the animation, everything should be fine. And then I'll describe why the percent error is negative, or could be negative, or would have been negative before. 1 second. Okay, so let's do Mirage. Okay, and here's what we got there. Okay, so the count's obviously increasing. I kind of like the way it looks. Yeah, that looks good to me. We can move the count a little bit to the right so that it's more symmetric. But that's okay. So the percent error could have been negative in the previous case because of the way I'm calculating the percent error. So let's go up and see where we calculate the percent error. The percent error is calculated here. So it's the temporary area minus the true area, and we know the true area as pi r squared, divided by the true area again, right? So in this case, if the temporary area is over the true area, we're set. But if the temporary area is under the true area, it's a negative, which basically means all we need is a absolute value, and that should fix it. I don't know, I think this looks pretty good. I think it looks pretty good. This particular file, I'm happy with. So I guess with that said, we can go ahead and end the stream. Again, tomorrow, guys, I'm going to spend a little bit of time working on some other things. What are the other things I'm going to work on? Well, I think tomorrow I'm going to see if we can draw the Batman function and integrate that, because I'm kind of looking forward to seeing how that turns out. That said, I think it's going to be a little bit tricky to analyze, or rather to, are you saying no to the Batman function? I think that'd be super cool. Anyway, so I think I want to try that. I think it's gonna be super cool and fun, and I think it will turn into a super cool visualization at the end, where we can show like the real power of Monte Carlo, being that we can integrate somewhat arbitrary potentials. The other thing too is this is so much faster than the other guy that we had, where we had vectors and stuff being read in. Okay, so this is mostly available on GitHub except for that last thing with the count. Why not? I'll go ahead and add that in too. So let's do git commit a Monte Carlo visualization.cpp, and let me say -m, adding in count to count value to upper right of visualization, and that is that. Git push. Maybe it's the one described by number file. I don't know who all described it, but I do know it's available mostly here is where I'll be getting a lot of my information from. So this is the function I was thinking about working on tomorrow. I'm pretty excited about it. I think it'll be a lot of fun. And hopefully, because it is a function, we should be able to check. The only problem is I'm not sure how to do this. We need to be able to check, is this particular point within the Batman function? And I have an idea of how to do that, but I don't know if it's going to work. So it's going to be kind of hit and miss. I don't know how it's going to work, but we'll see. And the nice thing too is that we do know the area on the inside, so we can clearly find a % error without too much trouble. It is probably the same function. Open link.
So we're going to do.
It's probably this one. Yes, it is exactly that one. Okay, heart function. We could also do that. In fact, the heart function I think would be kind of nice. I don't know. We'll see. We'll see how it goes. Anyway, guys, that's what I'm going to try. We'll see how far we get. Thanks, guys, so much for watching. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you around next time for the next episode of Simuleos, where we try to integrate somewhat more difficult functions, whether it be the Batman function, the heart function, I don't know, something that looks a little bit different to kind of get the idea out there that we can integrate somewhat arbitrary shapes with Monte Carlo. And that's about it. Again, this visualization will be available on my YouTube channel pretty soon. And that's about that. See you around, guys. Have a fantastic day. Bye.